Okay, so with the solution concentration terms, specifically today, we're going to talk about the units. So as you can see, each different equation that we have to use to find solution concentrations comes with different units. Some of them have no units, some of them are specifically in percents, and then some of them are your moles over kilogram. So we're going to start with the percent ones. So as you can see here, we are talking about the mole fraction, and that is your amount of solute in moles over your total amount of solute in solvent. So I think of this as pretty much your solution. You're adding your solute over your solvent in moles, and most of the time I've noticed that they'll be given in moles. If they're given in grams or something like that, it's a pretty easy conversion from moles to grams or anything like that. And we'll see an example here in a second. So pretty much when you do your solute over your solute in solvent, you are going to multiply that by 100. So you're most likely going to get a pretty small number, and then you are going to multiply it by 100 to get the percent. And then you're going to write it in percent, and overall it would be your mole percent. That's why your numerator and your denominator are both in moles, because it's your mole percent. And don't get this confused with your mole fraction, as we see here. Your mole fraction is the same exact thing, except you do not multiply it by 100. So you're probably going to get another pretty small number, maybe a decimal, maybe like a 1 point, something like that. But this one does not have any units. Yes, you start in moles, but you just write it as, say, like 0.64 or something like that. That would be an example, 0.64. So then we move up to molality and molarity. The way I can tell the difference in molality and molarity, first of all, they are in different units, in big M and little m, sorry. Let's see. So in molarity, you are going to multiply, or you're going to divide moles over your liters. And then molality is going to be moles over kilograms. I think about this extra L in here and think about how it's opposite R. You would normally think, since it has the extra L, you're going to put the liters on the denominator, but I have to think of it the opposite way. So if I see the extra L, I know I'm not using liters and I'm using kilograms. Both situations, you're going to put moles over something. We see that in pretty much, most of these equations on here. It's going to be your mass over your volume, specifically in the molarity. As I wrote this little note here. That more so goes for the bottom, but it is going to be mass over volume. Whoops. Then we move down to your parts by mass. Parts by mass kind of is different with the units. Here we see percent again. So we're just going to do, it's always going to be mass of solute over mass of solution, but what you multiply it by changes. So if you're doing percent by mass, obviously you're going to multiply by 100 again and get percent, just like kind of like we did with our mole percent, except we are putting mass over mass this time of the total solution. Multiply that by 100. If it's parts per million by mass, as we see here as a ppm, would multiply it by 10 to the 6th. And then if it's parts per billion, ppb, we'd multiply by 10 to the 9th. So you're just adding zeros every time, and then you just put the ppm or the ppb at the end of it. And then we move down to parts by volume. So there's parts by mass and parts by volume. Obviously, they differentiate between mass and volume, what you're solving for. So in parts by volume, it's the same, except you just do your volume over your solute over your volume of solution. So normally in, as we see here, liters. And then you use the same multiplication factors that are written out here to differentiate. So sometimes it can be percent. You multiply by 100, or parts per million, multiply by 10 to the 6th, or parts per billion and multiply by 10 to the 9th. So now we are going to do an example. Let's see here. Well, let me find a good example. We are going to do this one for molarity. Just let me get this all erased. So as you can see, let's start off with just reading the problem. As we can see, it is big M, and it's an R instead of an L. So that's how you know we're going to do liters, or moles over liters. And we're dealing with your solution and your solute. So we have 1 mole. I always go through my problems and underline. So 1 mole of sugar in, I think N is a pretty big deal, 125 milliliters of solution. Whoops. So first of all, I'm going to think about, we're using liters, so we can easily go from milliliters to liters by moving your decimal 1, 2, 3 times. So multiplying or dividing by 100. So 125 milliliters goes to 0.125 liters. And then you leave your 1 mole of sugar the same because we are using moles. So since we're doing molarity, we're going to put our moles. So that's our 1 mole sugar. I'm going to abbreviate over your liters that we found, which is 0.125 liters of your solution. I did also forget to mention, we know that our mole of sugar is the solute because it is being put in something. That's why I underlined the N. That's how we know it's the, we differentiate the solute and the solution. So once you get this over this, you divide, and you can see that, whoops, I can't write this one, M equals 8, and let's go back up here to our table. We're solving for molarity, so it's a big M, but our units are moles over liters. So let's remember our sig figs, 8.00 moles, over liters. And that is your example of molarity. So I hope all this made sense, and now I hope we can understand our units for all our solution concentrations a little bit better.